Welcome to the deep dive. We're your guides, and we're here to take that stack of source material you send over
Yeah, dive right in.
and really pull out the essential knowledge, the stuff you absolutely need to know. Think of it as, well, a shortcut to getting properly informed.
That's the idea. We cut through all the noise, all the extra detail, and get straight to the core insights. It's about understanding what really counts.
Okay, so today our deep dive is focused on a pretty big decision for a lot of folks, making a smart investment in a CNC lathe.
Right. A significant purchase.
And the source material you gave us is this really comprehensive guide. It lays out the key things you really need to weigh up before you sign that check.
Yeah, and our job here is to unpack those core elements of the guide flags, the things that separate a machine that's genuinely productive, a real workhorse.
From one that just causes problems.
Exactly. A
Huh.
frustrating mistake. So we're digging at those crucial bits of wisdom directly from the source you provided.
And the guide, it frames these as the heart and soul of the lathe. Understanding them is just fundamental. So we're talking accuracy,
Hmm.
speed, but specifically how it links to feed rates,
Yeah, that balance is key.
turret capabilities, and finally the CMC control system itself. The brains of the operation. These aren't just specs on a sheet, are they?
Not at all. They define what the machine can actually do for you. And, the guide subtly points this out too. They all kind of interact, they influence each other.
Yeah.
It's the whole package that matters.
Okay, let's dig into that first one then. The source puts accuracy right up front, focusing on surface finish. Now, if you've ever battled with inconsistent finishes, or worse, had parts rejected, well, you know how critical this is.
Oh, absolutely. The source really hammers this home.
Yeah.
Surface finish, often measured with things like RA or R6s,
Hmm.
it's just non-negotiable for quality parts.
Right.
It mentions typical ranges. Like for general turning, maybe in a RA of 1.6 to 3.2 micrometers is okay.
Okay.
But for precision stuff, you're often looking at much finer finishes. RAD 0.8, maybe even Rs Mil VO 0.4 to 0.8. That's a big difference in how smooth the surface feels and looks.
And the million-dollar question the guide tackles is, how do you actually get the finish you need? Consistently. It's not just about buying a fancy machine, is it?
Definitely not. No, the source breaks it down nicely. It shows it's a whole system. First off, tool selection, hugely important. The material, carbide, ceramic, CVN, that's vital.
Yeah.
But also the tool's geometry. The guide specifically calls out the nose radius.
Ah, right.
Yeah, a slightly bigger nose radius can actually give you a smoother finish, assuming the same feed rate. And obviously using sharp, good quality tools.
Yep.
That's just baseline.
So the right tool, right shape. Step one, what else does the source highlight?
Well, next up are the machining parameters, how you actually run the tool.
Okay.
The source talks about cutting speed, avoiding extremes that cause problems like built-up edge or too much wear, but it really puts a lot of emphasis on feed rate.
The speed the tool moves.
Exactly. And this is a key takeaway from the guide. Lower feed rates generally mean a smoother finish.
Right, because the little marks the tool leaves are smaller.
Precisely. The cusps are closer together, and the guide also mentions using light depths of cut for those final finishing passes.
Okay, so tool choice, how you run it, and the machine itself. It must play a role too.
Oh, absolutely. Machine condition is fundamental. The guide points to things like machine rigidity, how solid and resistant to vibration it is, minimal spindle runout, good vibration damping, a machine that's shaking or flexing.
Yeah.
It just can't hold tight tolerances or produce a really fine finish.
Stands to reason.
And regular maintenance, obviously, keeps everything in check. Oh, and coolant. Proper coolant use is critical, not just for temperature control, but getting chips out of the way efficiently. You don't want chips getting recut or scratching the surface.
That's a great breakdown from the source. It really paints a picture. You need to think about the lathe's built-in capabilities like rigidity and combine that with how you choose your tools, set your parameters, even manage your coolant. It's like an ecosystem for quality.
That's a good way to put it.
Mm.
It's about having the right foundation, the right machine, and knowing how to use it effectively. The guide makes that very clear.
Okay, so moving from making good parts to making them, well, efficiently, the source dives into speed. Specifically, that balancing act with feed rates. The common problem here is, cycle times dragging on forever or just chewing through expensive tools way too fast.
Yeah, the guide addresses that directly.
Mm-hmm.
Feed rate, how fast the tool travels along the part, It's a fundamental control, but it's not just about pushing it as high as possible.
Right.
The key insight here from the source is that finding the optimal feed rate is always a balance. You're balancing raw speed against, well, surface finish quality, dimensional accuracy, and making your tools last a reasonable time.
I think the source mentioned learning that the hard way, didn't it? Just cranking up the feed seems faster. But it can lead straight to scrap parts or broken tools. So how does the guide break down those impacts? Higher versus lower feed rates?
It uses a really clear comparison. For surface finish, like we said, higher feed rates generally mean a rougher surface, more pronounced tool marks.
Okay.
For dimensional accuracy, higher feed rates can increase the cutting forces. That might deflect the tool or the part slightly, hurting accuracy.
Oh.
Tool life takes a big hit, too. Higher feeds mean more heat, more stress. Tools wear out or break much faster.
Right.
And while production efficiency seems better with higher feed rates, you're removing material faster, you have to constantly weigh that against possibly losing quality or just burning through tools.
So this is constant negotiation, really. Varies job by job.
Exactly. And the guide points this out clearly. You'll strategically use higher feed rates for roughing when you just want to hog out material quickly.
Intense.
But then you'll switch to lower feed rates for finishing passes. That's when accuracy and surface quality are the top priorities.
Yeah.
And crucially, the material you're cutting makes a huge difference. Softer stuff can usually handle higher rates than, say, tough alloys.
That roughing versus finishing distinction seems really key. Understanding that whole interplay helps you program jobs to be genuinely efficient. Good parts, good tool life, not just fast on paper.
Right. It's about being strategic with speed, informed by the material and what you need the final part to be like. The guide really emphasizes that.
Okay, let's move to the third factor, turret capabilities. This really gets into the machine's ability to handle more complex parts and cut down on manual steps, doesn't it? The problem here is often slow manual tool changes, bogging things down, or just not being able to make certain features without moving the part to another machine.
Yeah, the source really underlines how central the turret is to the lathe's flexibility and efficiency. It even shares a story about a shop that started with simple parts, but then found their basic turret was holding them back as jobs got more complex. They needed an upgrade specifically, live tooling and a Y-axis.
And that made a difference.
Huge difference, apparently. The guide says it opened up totally new types of work for them and boosted accuracy because they could do much more in one setup. Done in one, you know.
That anecdote really hits home why this stuff matters. So, based on the guide, what specific things should you look at in a turret?
Okay, the source lists several key points. First, the number of tool stations. Simple enough. More stations, 8, 10, 12. The guide even mentions 24.
Wow, 24.
Yeah. It just means you can load up more tools at once, fewer manual changes between jobs, and a better chance of finishing a complex part in one go. Done in one.
Right, fewer setups means the machine is cutting more, less sitting idle.
Exactly. Then there's the tool change time itself, sometimes called chip-to-chip time.
Okay.
In production, even shaving off fractions of a second each time the turret indexes. It adds up over a shift. So faster indexing means more efficiency.
And that capability from the anecdote, the upgrade they needed.
Right, live tooling or driven tools. The source highlights this as a major step up.
What does it let you do?
It lets the lathes perform operations like milling, drilling, tapping, things you'd normally need a milling machine for. But you do it without taking the part out of the lathe.
Ah, okay.
It's a massive boost for accuracy, eliminates errors from refixturing, and obviously saves handling time. The guide suggests looking for standard holder types, like BNT or VDI.
So it basically turns the lathe into a sort of turn mill center.
Pretty much, yeah.
Oh.
And building on that, the source talks about Y-axis capability.
Okay, what's that add?
That gives you tool movement perpendicular to the usual lathe axes, X and Z, so your live tools can machine features off the center line of the part. Think slots or holes on the side.
Got it. More complex geometry in one setup.
Exactly. It just opens up more possibilities for complex parts without needing secondary ops.
So live tooling and Y-axis, those are the real game changers for complex parts on a lathe. What about just the basic structure of the turret?
Good point. The guide also mentions the turret's rigidity and clamping. Especially if you're doing heavy cutting or using long tools like boring bars, the turret needs to be really solid. It has to hold those tool holders securely, accurately. Any flex there impacts the part.
Yeah, accuracy and finish again. Makes sense. So the main takeaway for you, the listener, seems to be really look at the turret's capabilities, especially live tooling, y-axis, and match it to the complexity of your current parts.
Hmm.
And maybe even more importantly, the kinds of parts you want to be able to make in the future. Investing a bit more upfront in capability could really pay off later.
It's about buying future potential, not just what you need today.
Okay, our fourth and final pillar from the source, the CNC control system. You called it the brains of the operation earlier.
Yeah.
And this is where people often feel, well, a bit overwhelmed, right? So many
Yeah.
options, features, worrying about the learning curve for operators.
The guide is spot on here. The control is absolutely critical. It's what you interact with every single day. It dictates how easy it is to program, what the machine can actually do, and frankly, how productive and headache-free the whole experience is.
So what key features does the source say you should be evaluating?
It lists several really important ones. Ease of use is huge. The source highlights things like conversational programming.
What's that exactly? Like menu driven?
Yeah, basically.
Yeah.
It helps operators create programs for simpler parts without having to write lines and lines of G-code. Big time saver for some jobs. It also stresses good graphics and simulation. The author specifically says they always look for good simulation.
Right, because it lets you check for crashes before they happen.
Exactly. Verify the toolpath, avoid collisions, saves machine time and potentially costly mistakes. Cheap insurance, like you said.
Totally. What else?
Then there's precision and performance. This is about the control's processing speed and features like look ahead, which help optimize the tool's motion, especially on complex curves. A faster, smarter control helps achieve both speed and quality finish.
And it needs to handle all the axes, right?
Yes, multi-axis control.
Yeah.
Your basic lathe is X and Z, 2 axes. But if you have live tooling, like we discussed, the control needs to handle the C-axis precise spindle rotation.
Mm-hmm.
If you had a Y-axis, it needs to manage that too. You got to make sure the control can actually drive all the physical axes the machine has.
Any other big considerations for controls from the source?
Yeah, crucially, compatibility and support. Does it play nice with your CAD/CAM software if you use that?
Hmm.
Is there good, reliable, local technical support available? That can be huge when something goes wrong.
Good point.
And what about training? The guide notes that support and training often get overlooked when buying, but they're critical for actually getting the most out of the machine long term.
The source even had that table comparing some common control brands, didn't it? What were the main takeaways there?
Yeah, it gave a useful overview, kind of
Oh.
based on general market perception and the author's take.
Yeah.
It grouped them broadly. First, Chinese brands like GSK, KND, HNC,
Okay.
generally positioned as cost-effective, popular especially for small to medium shops. Pretty straightforward operation, good for general turning.
Mm-hmm.
The source puts them in the sort of mid-low price range.
Right. And then the big international names.
That group included FANUC, Siemens, and Heidenhain. FANUC was described as really robust, super reliable, maybe the most common worldwide.
You see it everywhere.
And a big plus mentioned was, once you learn FANUC, you can probably run a ton of other machines out there. Siemens was seen as highly integrated, often with a great user interface, really strong for complex multi-axis stuff, automation, and powerful conversational programming like their shop turn. And Heidenhain, often known more for milling, but used on high-end lathes too, especially where top-tier precision is the absolute focus, known for complex programming with their Klartex system.
And the sources table showed these generally cost more, right?
Correct.
Yep.
FANUC and Siemens typically listed as high-end price-wise. Heidenhain, with that super high precision focus, often even higher. The table was handy, comparing things like their typical user focus, conversational features, graphics, precision level, market share.
So the guide's message on controls is, you've got to weigh things up. Like operator familiarity, what your people already know. How complex is your work now and in the future? Any specific industry needs. Aerospace sometimes prefers certain brands. And budget, obviously. But it also showed that, other systems offer real value, too, especially for general turning work.
Yeah, it's about finding the best fit, the control that matches your operation, your parts, and your team skills.
So let's pull this all together, then. From this deep dive into the source material you provided, we've unpacked these 4 pillars the guide says are just fundamental for choosing a CNC lathe.
Right.
We've got accuracy, especially surface finish, understanding that speed and feed rate balance,
The trade-offs.
matching the turret capabilities to your parts and your efficiency goals, and picking the right CNC control system to run it all.
And the guide's core message, really, it seems pretty clear. Making a sound investment isn't just about finding the cheapest machine or the one with the highest RPM on paper.
No.
It's about really thinking through these key factors, analyzing them, and matching them squarely to the kind of work you do, the quality you need, and the efficiency you require.
Which leads us nicely into a final thought for you, the listener, building on what the source implies. Investing in a CNC lathe. It's more than just buying equipment for today's jobs, isn't it?
Definitely.
It's really about buying capability for the future. So how might the choices you make now, particularly around turret flexibility, like getting that live tooling or Y-axis, or the power and usability of the control system, how might those choices directly affect the types of jobs, maybe higher value, more complex jobs, that you'll actually be able to take on and do profitably, say, 5 years from now? Something to think about beyond just that initial price tag.
That's a really important perspective. Thinking ahead is crucial for a smart investment like this.
Absolutely. Well, with that, we'll wrap up this deep dive. A huge thank you for providing the source material that let us explore these really critical factors in picking the right CNC lathe for your specific needs.
It was good to dig into the details and pull out those key insights.